Now that we have installed various programs, it is time to work on the first Git project. To get started, we create a folder somewhere on the computer. In the home directory, in a cloud folder. It does not matter where. We start VS Code and open the just created folder. For this tutorial, we name the folder Tutorial Repo. The first time we open a folder, VS Code asks us whether we trust the file authors. Since it is an empty folder which we just created, we can safely answer yes. This is an important question. Do not hit yes for any random project you downloaded from the internet. If you do not fully trust the authors, click no. You can still browse the file, but a lot of code execution capabilities, etc., will be turned off. You can switch to trusted mode at any time. Clicking no is not final. Next, we open a terminal by selecting it from a drop-down menu or by pressing Ctrl-Shift-Backtick. The advantages of doing this in VS Code instead of using the regular terminal on Linux and Mac and Git Bash on Windows are that it looks visually similar on all operating systems and that we have the terminal in the same window as other VS Code functionality that we will showcase. It opens the default terminal on all operating systems, which is what we want on Unix-like operating systems. On Windows, said default terminal does not understand Git. As we recall from the Git installation, we have installed a separate terminal for that purpose on Windows. To open this Git Bash terminal, we pick it from the drop-down menu for creating a new terminal. Once we have access to the Git-capable shell, we start configuration. There are many settings that can be altered. You can find a full list on the Git website. The two entries that you must define are username and user email. You're free to pick whatever, but it is good practice to stick with the GitHub username, SoDa test in our case. The global flag specifies this username for all Git projects on this device. If you keep your Git projects local or in private, that is not publicly accessible, GitHub repositories, it is fine to use your actual email address in the Git configuration. Yet, if there is a chance that you ever publish something publicly on GitHub, you should choose the no-reply email address that GitHub creates for you. To obtain it, we log into GitHub and open the settings. We select the Emails tab, turn Keep My Email Addresses Private, and Block command line pushes that expose my email on. Copy the @users.noreply.github.com address and return to VS Code. We set the user email with git config. That is all we must configure for Git. Windows users are now probably done. They have already chosen a number of configurations during installation. There are many more configurations that you can tweak, but the defaults should be fine for beginners. Linux and Mac users, in contrast, have only modified username and email. In order to mimic some of the Windows choices on Linux and Mac, we add more configurations. We enter this line to specify VS Code as the default editor. Windows users can ignore this section and skip ahead a few seconds until after the configuration. Next is replacing the default branch name master with the word main. Once everything is configured, we initialize our first Git project with git init. Git init creates a hidden .git folder in the current directory, which marks the directory as Git managed. To turn a directory back into a non-Git directory, just delete the hidden .git folder. It is that folder that stores everything Git-specific about the project, including previous file versions, etc. A project tracked by Git is called a repository. For us to explore the capabilities available in a repository, we need to add some content. Click on the New File button in the Explorer. We name it readme.md, and VS Code automatically opens the empty file, only displaying a placeholder message. Next to the file name, we see a U, which stands for untracked. There are 3 stages in local Git: the working directory, the staging area, and the repository. The working directory contains files whose current state has not been inserted into version control yet. That can be a new file, or a file that you have changed or deleted since you last asked Git to record its state. The staging area holds files which are ready to be inserted into the next version. And the repository holds the contents that have already been inserted. It is the collection of past versions. Only states that made it to the repository stage can later be recovered. So unlike in cloud storage software, such as Dropbox and Google Drive, where each time we press Save, we create a recoverable version. We manage Git repository versions independent of how often we write a file to disk. A version, called a commit in Git, is not an update to an individual independent file. It is a snapshot of the entire project. That is not how Git stores a commit internally, but is a way to conceptually think of a commit. What this implies is that you can group changes across multiple files into a single commit. Assume that you modify the name of a folder and update the file paths in all scripts calling a file from that folder. Then you pass all these updates as a single commit, because the changes are part of the same step in the project's progression. To practice these concepts, we fill our README file with a line of text. We use Git status to list files currently in the working directory and staging area. As already indicated by the U next to the file name, in VS Code, the README is currently untracked, meaning it is in the first stage, the working directory. The Source Control tab provides a beginner-friendlier interface for controlling and visualizing Git repositories. And there are VS Code extensions and other external software that takes this way farther. While these tools are convenient, we recommend to, at least initially, manage Git from the command line to build a good understanding of how Git works. We use git add to move the file from the working directory to the staging area. The dot is a placeholder and means everything from the working directory. Instead of the dot, we could have used the file name. In research projects, you often list individual files rather than adding everything, either because some files are not ready to be submitted or because not all changes should logically be grouped into the same unit, that is the same commit. In VS Code, the file is now listed under Staged Changes, and the letter next to the file name switch from U to A. From the staging area, we commit the file into the repository with a commit message. Commit messages should be informative. For the first commit, it is fine to write initial commit. After that, commit messages should adequately describe how this commit changes the repository. Avoid messages like yesterday's work. Prefer wording such as add temperature simulation. If you would like to write a whole paragraph instead of only a title, omit the M flag and Git opens a new text editor window for you. Close that window to submit the long message. Write messages so that you and your co-authors can understand them much later in the project's lifecycle. Apart from commit messages, you can label commits with tags, but that is beyond the scope of this short tutorial. Once a commit has gone through, VS Code displays it in its graph pane. Next, we modify our just committed text file. The file is now marked with the letter M because Git is already aware of the file, but not of its current state. The editor marks the altered line with a colored bar. We use Git status again to list changed files, which VS Code is already showing us through its interface. We add the changed file from the working directory to the staging area. As we commit the state to the repository, the commit shows up in the graph. Git log displays the history in the terminal. At some point, its output will be rather long. In that case, we do not have to navigate through all of it. We can exit at any point with the letter Q. So far, we have been working on a linear history of the project. Sometimes this is not flexible enough. Assume that your research project is reaching an end and you want to rewrite the draft for a working paper version. Instead of directly amending your main draft, which you're still sending out to interested colleagues, you want to experiment with the working paper version on the side and decide later which of the new directions actually make it into the official draft. This is a use case for an additional branch. Branches are parallel versions of a project. We can modify a branch without affecting other branches. Once we are done with the work on a branch, we can merge its changes back into the main version of the paper. Branches are particularly essential in co-authored projects. Multiple people work on different extensions at the same time and do not want to incorporate anything into the official version without consulting their co-authors first. Hence, they create various branches and discuss before combining them back together. In modern Git, you move between branches using the git switch command, followed by the branch name you want to switch to. The C flag in our example means that the branch does not exist and that we want to create it. So, we create and switch to a branch named Working Paper. VS Code shows in various locations of its interface that we are no longer in the main branch and are now in the working paper branch. The initial state of the new branch is a copy of the repository version that we switch from. That is, the latest commit on the main branch. Git branch lists existing branches in the console and marks the currently active one. We add a file on the new branch, and we add and commit the changes. Switching back to the main branch, we see that it is unchanged. It is still in its old state. The latest commit on the working paper branch has no effect on the main branch. Git diff main working paper lists the difference between the two branches. Git diff can show differences between a lot of states, including two branches, two commits, or working directory and repository. Git merge merges the changes on the working paper branch into the main branch. The state of the main branch is now identical to the working paper branch. If we had modified main after splitting off working paper, Git might not simply have been able to append the working paper branch's commits on top of main's history in what is called a fast-forward merge. Git is sometimes unsure of how exactly you want changes to the same files to be joined. That creates a merge conflict, in which Git marks unclear lines in a file. You then have to open the file and edit these lines manually before Git proceeds with the merge. Yet, as mentioned, in our merge here, there is no merge conflict. We no longer require the working paper branch and delete it with git branch d. Listing our branches with git branch attests that the working paper branch no longer exists. Besides switching between parallel versions of the project, that is, the branches, we can move back in time to a branch's past commits. Git checkout head -1 moves to the previous commit. Head -2 would move back 2 commits, etc. Instead of jumping with these relative distances, you can also check out a commit via its hash, which is the identifier that git log shows. Git switch main returns us back to the latest commit on the main branch. To delete all changes made in the last few commits, we utilize git reset hard and the hash of the commit after which we want to discard all changes. Be careful with this. Everything after this commit will be irrevocably gone. Omit the hard flag to keep the changes in the working directory instead of deleting them. This limited overview of some of Git's local functionality should be enough to get you started. In case you are interested in a deeper dive into local Git methods, you can find many longer tutorials online. To comply with the purpose of this video, we keep the introduction short and move on to the next topic. Git with GitHub. GitHub is one of the online platforms for collaborating with others on Git projects. Never share a Git managed directory through regular cloud storage like Dropbox or Google Drive. That would defeat the purpose of Git. Instead, share through Git itself and turn to a custom platform like GitHub for hosting. While there are alternatives to GitHub, the SoDa Replicator's AI checks are customized for this provider. The first step in making the previous section's Git repository available on GitHub is authenticating on the website and selecting the repository's element from the drop-down menu in the top right corner. We click on New to open the repository creation form. We choose a repository name, enter a description, and set the visibility to private. Private means that only you and collaborators who you explicitly invite to the repository can see it. GitHub offers to create README, gitignore, and license files for us. We reject it because for this tutorial, we create all files on our machine and then upload, not vice versa. The README is the main documentation and is the file that GitHub shows by default when someone visits the repository site. The gitignore file lists contents in our local project directory, which we do not want Git to track. One example are the DS-store files that macOS writes everywhere. These are irrelevant for the project's history, and we do not want to clutter our co-authors' machines with those files. The SoDa Replicator comes with a set of predefined gitignore files. Licenses determine how we permit other people to use our project and what our liability is. In private research projects, they are largely irrelevant because only we and our co-authors have access anyway. Licenses become important once a project is public. After we create the repository, GitHub presents us with instructions for 2 scenarios. The first is for cases in which we do not have a local repository yet. The second is for our setting in which we already have a corresponding local repository on our machine. We can also choose between two encrypted protocols, HTTPS and SSH. HTTPS is the protocol over which we communicate with websites in the browser. SSH is the protocol handling shell access to cloud servers. In this tutorial, we stick to the HTTPS default because it's quicker and more beginner-friendly. You should consider switching to SSH as you become more technical, especially on Unix-like operating systems. We copy the first line from GitHub and execute it in the terminal. It connects our local repository to the one on GitHub. It calls the remote version on GitHub origin, which is the standard name and which you should usually keep. The second line on GitHub renames the default branch to main. We skip it because our default branch already has that name. The third line uploads the commits of our local main branch to GitHub. The U flag sets up a tracking relationship between the main branch on our computer and the main branch on GitHub. This allows us to omit origin and main in future transfers. As long as we are on the main branch, Git push knows which remote branch we target. Hence, we specify the U just once per branch and machine. For training purposes, we will still write origin and main for the rest of this tutorial, despite it being unnecessary. Beware that we need to push to update GitHub. The git commit command alone exclusively inserts a commit in the local repository on our machine. We have to authenticate the first time we interact with GitHub from a given device. VS Code asks us for permission, and we allow it. We enter our username. In the automatically opened browser window, we click Continue. We authorize VS Code to access our GitHub account, and we confirm to open the VS Code URL handler. Back in the app, we see a message documenting the successful transfer. Authenticating through VS Code is fast and sufficient for this tutorial. For a proper GitHub connection that multiple apps on your device have access to, you should follow the regular GitHub authentication, which we link to in the description. To keep your research safe, you should activate two-factor authentication. After refreshing the repository page on GitHub, we see our project's contents. It shows title and description, information on the last commit with username, message, hash, and relative time. If we had multiple branches, we could switch between them through the drop-down menu. We add our collaborators under Settings, Collaborators. Browsing information on GitHub can be a good alternative for use cases when the terminal does not provide an appealing user experience. One example is the changes made by commits, so an output of the git diff command. On GitHub, we first open the commit history with a click on the commits counter. We pick a commit, and we obtain a visually improved version of what git diff prints in the terminal. How do we transfer information the other way around, from the remote to the local repository? To simulate the situation in which our co-author has pushed a commit to GitHub, I have altered the remote version of the README. We now want to download these latest updates to our machine so that our local repository is up to date with the remote. We could obtain the remote file and directly overwrite our local version, all in one command. However, for this example, we are more careful. We want to assess first how our local version differs from its GitHub counterpart. Git fetch retrieves the GitHub commits without incorporating them in our local files. Git diff then allows us to compare the two states. Our co-author added "hello there" to the README. A git pull both fetches and implements the changes. Our README is now updated. In cases where we already know that we want to incorporate the remote state, we can skip git fetch and immediately call git pull.